I said this was in my drafts, and like, it didn't seem good.
Hi everyone, my name is Flanagan, and today I'm the group leader for Group 1, and I'm going to do the gas turbine jet engine experiment. So a little introduction and objectives. The purpose of this experiment is to gain understanding of the turbogen gas turbine electric generation system as a whole, and the details of the engine and generator sensors and the controls making up the system. We want to record and analyze the data collected during the experiment to analyze the jet engine's performance. So a little background. Gas turbines have a history dating back to the 20th century, primarily developed for aviation purposes. This development was significantly influenced by the need for more powerful and efficient propulsion systems for aircraft. Over time, their application expanded to various industries such as the power generation, marine propulsion, and more. The jet engine is a type of gas turbine. It is a key technology in the aviation industry, enabling aircraft to travel at high speeds and altitudes efficiently. The constant demand for enhanced performance, fuel efficiency, and environmental sustainability has driven continuous research and development in gas turbine technology. So a little theory. The gas turbine jet engine cycle is based on the Brayton cycle. It's a thermodynamic cycle that describes the process involving a gas turbine engine. It consists of four main processes. You have the isentropic compression. Air is compressed isentropically by the compressor. You have the constant pressure heat addition. Fuel is ejected into the compressed air and burned into the combustion chamber at a constant pressure. You have the isentropic expansion. High pressure gas expands through the turbine, and then we have constant pressure heat rejection. The hot gases are expelled to the atmosphere. Some of the components of the jet engine cycle: you have a compressor. It's responsible for compressing the incoming air to high pressures before entering the combustion chamber. Next, you have the combustion chamber, where fuel is mixed with compressed air and ignited, leading to high temperature, high pressure gas mixture. The next component is your turbine. It extracts energy from high temperature, high pressure gas to drive the compressor. And in the case of jet engines, they use thrust for propulsion. And then you have your nozzle. It accelerates the exhaust gases to generate thrust into the engines. So the equipment and setup, you have the SR30 engine, the TG2000 electric generator. You have your operating softwares, and then you need to wear the proper PPE given to you in the lab. So here is the operator panel. 1, 2, and 3 is your master switch and your start and stop buttons. 4 and 5 is your throttle power and your load lever. 7, 8, 9 is your turbine inlet temperature, your engine and generator speeds. 10 through 13 are your oil, engine, fuel, and starting air pressure meters. And then 14 is your voltage indicator, and 15 your generator rotor speed point. So this is what you'll see on your computer, the virtual instrument panel. T's 1 through 5 is your compressor and turbine exit and inlet temperatures. P's 1 through 5 is your compressor and turbine inlet and exit pressures. And then N1 is your engine RPM, and N2 is your generator RPM. So the startup procedure, you obviously want to turn on the system, verify that the generator RPM, engine RPM, and the temperature, turbine inlet pressure are displayed. You want to set your throttle to maximum power. Set the generator load lever to the pin position. Ensure the throttle lever functions through a full range of motion, and initiate the engine start. Once you do this, you start recording data. You want to record the compressor and turbine inlet and exit temperatures and pressures, the generator's RPM, engine's RPM, the voltage and current, fuel pressure, and you want to plot these measures on a value versus time. So on the left, I have a couple of equations, and on the right are a few cycles. So some of the equations you're going to need is the work done by the compressor, we worked on about the turbine, the enthalpy calculation, the efficiency of the turbine cycle, and the volumetric flow rate. And on the right, I have a PV and a TS diagram of the Brayton cycle.